Hi Leo students, Mr. Kaczynski with you, about to do the solutions for section 4.7, practice your skills. All right, first off, we're going to write point slope form of the equation for the line represented by each graph. Okay, so if we say take this point right here, which is at 1, 1, then point slope form of that equation would be y equals, well, we got to know the slope, don't we? So let's see, it goes up from 1 to 2, 3, 4, 5. So it goes up 4 and right 2. So 4 over 2 is 2. That's our slope. So 2 times x minus 1 plus 1. Now, if we want to use this point over here, then we could write the equation y equals 2 times, we got another point, don't we? 1, 2, 3, and 1, 2, 3, 4, 5. 3, 5, so x minus 3 plus 5. All right, so you can write an equation for any point that's on the line by just replacing this value that's being subtracted from x and this value that's being added off the end. All right, let's do it again. The coordinates of this point are 1, 3, and our slope is up 2 over 3, 2/3. So our equation will be y equals 2/3 times x minus 1 plus 3. Or we could use this point, which is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 4, 5. And our equation would be y equals 2/3 times x minus 4 plus 5. One more. All right, what's our slope? Let's figure that out first. We're going down 1, 2, 3, 4 units, down 4 over 1, 2, 3, so negative 4/3. We've got this point right here, which is at 1, 8, 7, 6. So let's go y equals negative 4/3 times x minus 1 plus 6. Or if we decide we want to use this point, 1, 2, 3, 4, 2, then our equation would be y equals negative 4/3 times x minus 4 plus 2. All right, now we're going to look at each graph, estimate the y-intercept, and then convert our point slope equations to intercept form. All right, so looks like the y-intercept on A is going to be, maybe -1 or -2. I'll use B to represent the y-intercept, so we'll say -1.5. All right, for B, my estimate is going to be, 1, 2, it's about 2.5, it looks like. And for C, 1, 2, 3, 4, 5, 6, 7, a little bit above 7, let's say like 7.1, I don't know. All right. And now we're going to actually convert equations into intercept form. All right, so we're going to take this blue equation right here. Y equals 2 times x minus 3 plus 5. We'll distribute the 2. 2x minus 6 plus 5. And then we'll combine like terms, and we get -6 plus 5 is -1. I guess I made it too difficult in that I estimated -1.5. It was -1. All right, and let's take, we'll take the top equation. The y equals 2/3 times x minus 1 plus 3. We'll distribute the 2/3. I'm going to make this 3 into 9/3 right now because I know I got to combine like terms. So -2/3 plus 9/3 is 7/3. So I said that the y-intercept was going to be 2.5. It looks like it's actually 2.3 repeating, 7/3. All right, and one more. I'll take the purple equation this time. Y equals negative 4/3 times x minus 1 plus 6. Let's distribute the negative 4/3. So negative 4/3 x plus 4/3 plus 6, but I'm going to make it plus 18/3 to get a common denominator there. And then combine like terms. 4/3 and 18/3 is 22/3 minus 4/3 x. So I said the y-intercept was 7.1. It's actually 7.3 repeating. 22/3 right there. Graph each linear equation on your calculator and name the x-intercept. Make a conjecture about the x-intercept of any form in that, or equation in that form. Okay, so we're going to graph this and look for the x-intercepts. Let's go to y equals. Clear these equations that I have in here. All right, punch this first one in, 2 times x minus 3. And let's graph it. And it looks like the x-intercept is 3. Trace 3, enter, yep. So x-intercept is 3. Okay, that's interesting because we're subtracting 3 right there. Let's go back and graph the next one. 1/3 times x plus 4. I think I know what the x-intercept is going to be. We'll trace it. It looks like it's negative 4. It is. And do you know what this last one's going to be? Hopefully you do. Negative 1.5 times x minus 6. And the x-intercept is going to be positive 6. Yep. So I guess my conjecture would be that the x-intercept of any equation in this form is always going to be equal to x1. All right. Then we've got carbon dioxide. It's a greenhouse gas emitted from the atmosphere into the atmosphere from a variety of sources. We're measuring the CO2 in the atmosphere atop Mauna Loa volcano in Hawaii each January. Okay, so we're going to define variables. All right, so our independent, or x, is going to be the year, and y is going to be the CO2 in parts per million. Yeah, we won't worry about the subscript. All right, graph your equation to confirm. Oh, we're supposed to write the equation of a line too. Well, so here's what I'm noticing is that this is going down 3, or no, sorry, up 3. Then it goes up 4, up 3, up 2. Every time the number of years goes up 2. So every 2 years, the parts per million of CO2 is going up a 2 or 3 or 4. I'm just going to go with 1.5 here to guess. So let's write our equation is y equals, let's go with 1.5 times x minus 1982 plus 341. And I'm just using the 1982 and the 341 right there. All right, so first of all, I've created a scatter plot. I entered all my data into L1 and L2. So let's show you what that scatter plot looks like. Zoom 9, there it is for all this data. Let's go in and see if my graph matches. 1.5 times x minus 1982 plus 341. Let's graph that. I liked it at first, but then it looks a little off at the end. Maybe we up our slope. Let's try 1.6, see if that works. I like that a little bit better. So let's get rid of this 1.6. There we go. Or 1.5, make it 1.6. There we go. Graph your equation, make sure it fits the line. There you go, I updated it. Use your equation to predict the concentration of CO2 will be 2020. Well, I've already got the graph, so let's go trace. If I press up, I can trace it. We're going 2020. The problem is when I put in 2020, it's invalid. So maybe we go, because my graph doesn't go out far enough, so let's go second graph. Go to the table. That's going to take too long to get to 2020, but I can go second table set, start at 2020. There we go. And then jumps right to it, 401.8. Parts per million. Okay. And I could get that also by putting the year 2020 into my equation. I'll show you that real quick. 1.6 times 2020 minus 1982 plus 341. There it is, 401.8. What would the x-intercept for the line be? So in other words, they're saying if we put 0 into this equation for y and solved it, what would that x-intercept be? Well, the easiest way to do it is probably from the table, but I got to go back to table set, and let's start it at 0. All right, it would be negative 2830. Parts per million. Does the real world meaning make sense? No, because you can't have negative amount of CO2. So I would say no. All right, according to your equation, what's the typical change in CO2 concentration each year? And that is 1.6 parts per million per year. How about this? We'll say an increase of 1.6 parts per million per year. All right, there you go. Those are the solutions to 4.7. Hopefully that helped and you identified any mistakes. Good luck and have a good one.